see that I'm interacting perfectly fine with Maya. It slowed down a little bit, but almost insignificantly. This kind of performance in Maya is probably, I dare say, a little bit more than if you had a big robot running through a sink. I have a lot of benchmarking examples of classic visual effects scenes, and they actually run slower than this. So this is probably running about 10 frames per second, whereas they'll run at more like 8 or 7. So the great thing about this is we can play about with this in a more interactive manner. Now, this kind of speed is what we in visual effects will refer to as interactive. Not maybe in the video game market, but this is pretty awesome. Being able to drag things around, splash things about. Let's make that a bit bigger. It's around, go through here. Create splashes and things. So, kind of neat. We can also, because we're rendering at the same time as doing our simulation, you'll have to forgive the resolution here. Maya is used to being run at a much, much higher resolution, so the user interface usually shows a lot more. But this is doing an actual screen space example of surfacing. This is a screen space, kind of a clever hacked method done by one of my colleagues, but it's enables us to sort of visualize it more like water or something like that. But with all this time with the simulation sector, we could be doing incredibly detailed volume rendering or something like that, with shadows and we've got a little bit of refraction going on here, but we could be doing it properly. We have so many clock cycles to spare on the GPU. Show you another example here. This is a Kool-Aid example. The NVIDIA logo exploding view. In fact, let's do this in the literally Kool-Aid example. So you see, it's kind of neat the way we can just play about with this stuff and prototype our visual effects or something like that. This is created just purely as a demo, and what we've done is actually made this source code available to large studios and ISVs who are interested in trying to do this, because it's not our job to make these cool tools, it's up to them.
So for those that aren't as close to using this on a daily basis, how would you have worked in the past? Like, what would the process look like to get these types of...
Oh, it's painful. Yeah, I mean, you can't. There's sort of different ways of working in visual effects. There's the very contrived, deterministic manner of building large graphs and slowly looking at each part of the graph to see how the changes you've made sort of affect everything to the end result at the end, and then putting them all on the server farm and just hoping that this massive graph you've created, like your nuke graph or shape graph, is going to end up with the right result. And more often than not, it doesn't. You have to go back and fix it. Well, this is kind of the same thing. Visual effects tools, a lot of the time after you run offline, simulation tools, and you look at the result afterwards and you see what it's like, and you come in the next day, and if it's wrong, you do the whole thing again, you make tweaks, and it's not iterative in that whole, relighting kind of paradigm that everyone's trying to get to, where the director can be hanging over your shoulder going, make it fluffier, or something like that. Well, this kind of technology pushes us in that direction. The idea that the visual effects artist could splash water over Shrek's body or something like that, and the director just goes, fix it. It's not. I want it to be more like this. I want it to be more gooey. I want it to be more slimy. I want it to stick to his body more. I want it to, and you could just fiddle with the numbers and change it and show it to him in front of him. So I don't think this is there yet because of the particle counts, but it's absolutely a step in the right direction. I mean, we can simulate here interactively 1 million particles, interactively. But that's not enough. I mean, visual effects needs, for really top quality final frame stuff, at least 100 million. But I think we're definitely getting in the right direction, and there are adaptive methods that will enable us to create simulations at, say, 10 million, which is a very feasible thing for maps the next generation, that would enable the director to be able to prototype those effects. So I think it's pretty exciting to see this stuff, and we're waiting for the ISVs to just start throwing this kind of technology into their platforms, into their software.
Cool.
Do you want to see the Galaxy?
Yeah, let's do that while we've got
Can we
it.
take like a flight now?
Sure.
Sorry about that. Yeah.
There you go. Let's see what we do.
Yeah, I mean, what's interesting about this is that Maya, anyone who sees this kind of really wants it. It wasn't very difficult to write. It took 5 weeks to write this, just for a demo before SIGGRAPH. And it hasn't yet made it into applications like Maya because Maya's got other things on its plate to deal with. So they can't move quickly like this, but smaller ISVs can. So I'm expecting to see this kind of technology come out pretty soon. I'll show you.
Could you more accurately articulate what technology it is that you're referring to on the slide?
Well, this is, I don't know if you saw my talk just before this. No, you didn't, of course not. This is leveraging the fact that Maximus enables you to simulate and render at the same time. But it's also leveraging the ability that the GPU is a discrete device. It's a separate device on the system. So Maya is primarily, almost entirely, a CPU-driven architecture. It has to do lots of complicated deterministic things based on modeling and skinning and all that, moving meshes around. And that's what people are used to, and that's the performance they expect. It's not like a video game architecture, which is really fast. So they work with this very complex CPU-based architecture. If you can simultaneously use the incredibly powerful GPU in the system to do all this simulation computation based on the movement of a character or something like that, while Maya then trundles on in the background doing all of its slow CPU-based legacy kind of mentality and things, then you can overlap the two things. And the other thing we can do is we can also render at the same time. So if you have a Maximus system, Maya can do all of the calculations of the dynamics of the character. We can simulate at the same time using the GPU, with CUDA, using the Tesla, and we can render it using the Quadro card. And Maya can also draw everything in the scene graph that is created with its textures and everything like that, all simultaneously. So you practically don't feel a frame rate hit at all. And suddenly you have interactive fluid dynamics. And the only thing you're limited by is how much memory you have in the graphics card, assuming you have a certain spec graphics card. And I think that's a very powerful way of working. It's not. A lot of people think it's a problem that the GPU is a discrete device. This is saying, well, actually, it's kind of an advantage. You can work at the same time.
So Maya is allowing you